Today my topic is my name is Jeevam J. Krishna. I am studying in CSCC section. My roll number is H2. Today my topic is principle and application of gas chromatography. Contents of gas chromatography: introduction, principle, instrumentation, working, evaluation, application, reference. Introduction: gas chromatography. It is a process of separating components from the given crude drug by using a gaseous mobile phase. It involves a sample being vaporized and injected onto the head of the chromatographic column. The sample is transported to the column by the flow of inert gaseous mobile phase. The column itself contains a liquid stationary phase which is absorbed on the surface of an inert solid. Principles: the principle of separation in GC is partition. The mixture of component to be separated is converted to vapor and mixed with gaseous mobile phase. The component which is more soluble in stationary phase travels slower and electrolyzed later. The component which is less soluble in stationary phase travels faster and electrolyzed out first. No two components have same partition coefficient conditions, so the components are separated according to their partition coefficient. Partition coefficient is the ratio of solubility of a substance disturbed between two immiscible liquids at a constant temperature. Instrumentation of gas chromatography. Carrier gas E common N2H2 argon. Same injection port, micro syringe, columns detectors. Thermal conductivity in short form TCD. Electron capture detector short form ECD. Flame ionization detector FID. Flame photometric FPD. Working: fill the syringe with sample, record the settings, column temperature, detector temperature and injection port temperature. Introduce sample into injection port by completely inserting the needle into the rubber septum. Note down the injection time. The sample gets vaporized due to high temperature of injection port and is swept into column by carrier gas. These sample components now get distributed between the gas and stationary liquid phase depending upon their soluble tendencies. The components with minimal solubility move faster and those with maximum solubility travel slowly. The components living in the column activate detector and recorder to give a plot. Evaluation: high equivalent to theoretic plate. It is distance on the column in which equilibrium is attained between the solute in the gas phase and the solute in liquid phase. Larger the number of theoretic plates, smaller the HETP, the more efficient the column is for separation. HETP length of column by 7, where n is equals to number of theoretic plates. Second point: retention time, defined as the absolute time taken by a sample to showing maximum peak after injection. Retention volume, defined as the volume gas required to electrowate about half of the solute through the column. VR is equals to TRX into F is equals to average volumetric flow rate, ml by minute, estimated by using soap bubble meter. Some gases dissolve in soap solution. Applications: qualitative analysis, by comparing the retention time or volume of the sample to the standard by collecting the individual components as they emerge from the chromatograph and identify these components by other methods like UV, IR, NMR. Second point: area under a single component election peak is proportional to the quantity of the detected component. Response factor of the detectors. It is done by direct comparison method. Direct comparison method: a sample C is sample C of yesterday, whereas is a response factor determined for every pure compounder using given conditions. Second, calibration curve. A graph is plotted by taking peak areas of y-axis and concentration of standard compound on x-axis. Concentration of unknown sample is then determined by plotting its peak area on same graph. Third point, internal standard method. A no concentration of internal standard which has similar retention characteristic as that of sample is added to both reference standard as test sample.